This video will describe how to take traces from LPWA HL7800 series modules. We'll first have to look at low-level debugging and root cause analysis on HL7800 modules. Firstly, debugging of mobile network connections sometimes requires a view into the lower layers of the mobile network connection. Therefore, it might be requested by the Sierra Wireless support to record debug traces to get better visibility on the lower layers of the module, which is often the only way to do a root cause analysis of an issue. Eventually, network-caused issues can be identified with the help of module low-layer traces. HL7800 series modules offer a debug interface via the debug UART0. This UART can be configured to expose a debug command line interface, short CLI, for lower layer analysis. For this reason, it is recommended that the debug UART is accessible also on application PCBs. Access via test pads can be sufficient. Now let's find out about taking traces from HL78 modules. In case the Sierra Wireless support requests traces, the customer will receive the following from the support team: a zip file containing the STT tracing tool as pre-built binary for Windows and Linux 64-bit, and a CSource file for any other architecture. The customer will also receive advice on which AT and debug CLI commands have to be issued on the HL78 module to enable the right debugging level. To perform a trace, the customer needs an additional PC to take the traces. The next thing that's needed is connectivity from this PC to the module's UART. This might be done via a UART to USB converter. In case the STT tool needs to be built from source, the relevant tool chain is required. The customer will also need access to UART0 for the trace tool, as well as access to UART1 for additional debug AT commands. And finally, the customer needs terminal programs such as Terraterm or PuTTY for CLI access. Let's have a look at hardware setup using the Sierra Wireless Revision 4 HL7800 series dev kit as shown on the screen. On one side, you will see the debug UART0 connected to the PC. You will also find the AT command interface on UART1. Both UARTs are connected via USB by using the embedded FTDI converter. We'll see this now in a practical session. In this practical session, you will see a Sierra Wireless Revision 4 HL7800 series dev kit getting connected to the PC. To ensure that it is known which UART gets which identifier, it will be sensible to connect one UART after the other, especially if a USB to UART converter is used. For this example, the device manager is used to identify the COM ports. In the first step, you will see that debug UART0 from the dev kit is connected and it appears with the identifier COM74. In the next step, the AT command UART1 is connected, which appears with the identifier COM78. As the trace tool will require the identifier, it is important to keep them and the mapping in mind. In case the Sierra Wireless support team requires low-layer traces, the support team will make the STT trace tool accessible. This might happen via the support portal or other file transfer platforms such as OneDrive or SharePoint. The STT trace tool typically comes zipped and contains a few files. Extract the zip file into a folder of your choice. Have a look into the README full ext.txt file for further information. Now open a terminal client such as PuTTY or Terraterm and access the AT command interface of the HL7800 series module. Go to File. Select New Connection. When the new connection opens, go to Port and select COM78. Click OK. To see if the AT command interface is working, enter AT and the console should come back with OK. In some cases, particularly if the UART was not clear, it might be required to complete this 2 times until the OK appears. The AT command interface is now ready. The Sierra Wireless technical support team will advise on which AT commands to be issued to enable the required logging capabilities. It is always recommended to capture the AT log next to the STT trace, as both together help to analyze the trace. It also helps to issue basic commands. For example, for better understanding of the firmware version, network settings, and other information. Check the main log setting AT plus SWI trace mode ? As well, and keep the value in mind. It is important to set the trace mode back to the original value after taking the traces, because the debug values are taking extra resources from the module. Now set the trace mode as required by support. In Windows, open a CMD command line and navigate to the folder where the STT tool was extracted and prepare to start the trace command. The trace command requires the debug UART0 COM identifier, in this case COM74, the baud rate, and a file name where the traces will be written. The baud rate can be, from modem perspective, maximum 921,600 in log mode. This is what the log mode recommends. However, ensure that your PC is able to handle such high baud rates. Remember to give the trace file a meaningful name. The STT trace writes dots to standard out in case data was received from the debug interface and written to the trace file. In a debug case, you might be advised to perform a number of AT commands to reproduce the issue. To end the trace, press Ctrl-C on the command line. Depending on the log load, this might be needed to be done more than one time. Pack the AT log and the trace file or files together and upload them to Sierra Wireless support. Beside the COM port names, taking traces under Linux is very similar. In case of a different platform, the STT trace tool is available as source in the zip file and can be compiled for other platforms. Check the README full ext.txt for compilation advice. That is the end of the walkthrough, and now you know how to take traces from LPWA HL7800 series modules.